Welcome students. Now in this video we are going to see what is the effect of the tool geometry on the machining. Okay. So here I have drawn the single point cutting tool. One by one we are going to see the angle and their effects on the various machining parameters like cutting forces, power consumption, okay, strength of the tool, impact load carrying capacity. So these are the some things. Okay, so see, let us take the first, that is our back rake angle. Back rake angle. So what is the back rake angle? So here it is, this angle is our back rake angle, this angle. Okay, so the back rake angle is what? It is the downward slope on the top surface of the tool measured from the nose to the rear longitudinal, from the nose to the rear longitudinal axis, or along the longitudinal axis, isn't it? Starting from nose to the longitudinal axis, whatever this downward slope we are having, okay, that slope is nothing but this back rake angle. Okay, so this back rake angle, say alpha b, is our back rake angle, isn't it? Now what will happen if we increase this back rake angle? Let us see in the orthographic view. So this is our back rake angle. So this is our back rake angle, alpha b. Okay, so see, when this back rake angle we go on increasing, we increase this back rake angle. So what is going to happen? See here, the tool is going to be more and more weak, isn't it? The tool is going to be, see, tool is going to be weak if you increase in this positive direction. See, please remember, this is the positive increase, okay, and in negative we are going like this. This is the negative rake, and zero rake will be like this. Zero rake will be like this only. So we are talking about when we increase this back rake angle, what will happen? सबसे पहले क्या होगा? The strength of the tool, what will happen? Definitely strength of the tool is going to decrease because tool is going to be weaker. If that, then load carrying capacity, of course it is also going to decrease. Load carrying capacity, if we see for this tool with the increase the rake angle, back rake angle, it is also going to decrease. See, now as this alpha b increases, you can see here the cutting forces and the power consumption. What is going to happen? Please remember that when rake angle increases, the cutting forces are going to decrease. Okay, so जैसे जैसे अल्फा बी का आप बढ़ाते चला जाओगे, then what happen? There will be only the point contact between the tool and the tool tip and the workpiece material, so that therefore the cutting forces are going to be less. As cutting force is going to be less, please remember power consumption is also goes on decreasing. Power consumption is going on decreasing. What is about tool life? So tool life का क्या होगा? What is happening with the tool life? See, as rake angle goes on increasing, what you can see here, this wear land. So this is the increase the rake angle. So initially say it was like this. So see, Tool life means what? We have already defined tool life means nothing but the time between those two successive regrinds. Okay, during the machining process, when the tool becomes blunt, it is not performing the cutting operation well. So what we are going to do? We are unloading the tool and take it onto the grinding table. So where we can give again the required angles, required geometry on the tool, isn't it? So here, so tool say tool getting blunt here, and this is the wear land. This is actually what? Wear land. So here see the wear land, I hatched it. Okay, here you have to immediately remove the tool and you have to send it for the regrinding operation, isn't it? But see, when this rake angle, back rake angle I am increasing here compared to this rake angle, this is the maximum, isn't it? So here you can see the wear land. So the time between two successive regrinds is maximum because the tool is taking more time to get wear out or getting blunt, so that I can remove it and I go for the regrinding or resharpening of the tool, isn't it? So definitely here is time is more, and see here the time is less, that is wear land is less here, here wear land is more. So I can use the tool for a maximum amount of time here compared to this rake angle, isn't it? So of course, when we go on increasing the tool life, go on increasing the back rake angle, tool life is going to increase. Please remember, tool life क्या होनी चाहिए? Tool life definitely goes on increasing. So this is the actually effect of this back rake angle on these machining parameters we are having with us. Now see, in positive, this back rake angle is positive. Maximum कितना positive जा सकते हैं हम? Up to 45 degree. Please remember, this positive rake angle up to 45 degree. Whereas when we are talking about the carbide tools, so please remember that the carbide tools are very weak in tension. Carbide tools, when we talk about the carbide tools, so they are very weak in tension, but they are very strong in compression. So the carbide tools, these were the first tools or tool materials on which the negative rake angle was provided. So this is the tool. Negative means in this side. When you provide the rake angle in this side, definitely what happened? You will get the negative rake. This is the negative rake angle. So with the negative rake angle, what is going to happen? See, now you can, by looking to the tool, you can say the strength of the tool is high. Strength of the tool increased. Okay, but here the contact between the tool and workpiece, as you goes on increasing the value of alpha b in the negative side, so there will be the maximum contact is going to happen with the workpiece and tool. So what will happen? The forces will goes on increasing and power consumption will goes on increasing. No doubt, strength increases, load carrying capacity of the tool increases. So for the case of carbide tools, we are using this negative rake angle. To have this minimum contact between this workpiece and tool, we generally maximum negative side back rake angle we are keeping up to 10 degrees, up to minus 10 degrees. Okay, we will not go beyond that, otherwise there will be maximum contact between the workpiece and tool material, so it will have the maximum cutting forces, maximum power and all. So this is the negative, this is maximum 45 degree positive, maximum 10 degree negative. And of course we are also using this back rake angle as a 0. See here the tool like this, no any rake angle is provided, this is the 0 rake angle, alpha b is equal to 0. So where to use this back rake angle as a 0? So please remember, in the case of thread cutting operation, थ्रेड कटिंग ऑपरेशन का अगर टूल देखा होगा, सो इट विल लुक लाइक दिस ओनली, थ्रेड कटिंग ऑपरेशन टूल. ओके, so it will look like this, zero rake angle. So thread cutting operation we are having, or we are using this tool with the zero rake angle. Or in the case of machining of the brasses, in the case of number 1 thread cutting, and number 2 machining of brasses, we are using this 0 degree rake angle. Please remember 0 degree rake angle. So please remember the value of the rake angles, it may be positive, 0 or negative. Okay, so thread cutting में actually होता क्या है? Okay, when you are go on cutting the threads, so whatever chip is going to produce in the thread cutting operation is directly getting lifted upwards. Okay, so this is the thread you are producing, so this is the tool here, so this is the workpiece on which you are producing the thread. So whatever the chip is produced here, it get directly cut or lifted upwards onto the rake face of the tool itself, so chip will not flow in the sidewise direction. So whatever the produced threads are definitely not getting damaged by this flowing of the chip. So chip is directly lifted and it is flow onto the tool directly like this onto the tool, so it will know having the flow in the sideward direction, so the threads are very safe. Okay, so the threads will not get damaged by this chip. So that's why this in the thread cutting operation we are using this 0 rake angle. And of course the brasses, to get the good surface finish, we can use the 0 rake angle in case of machining of brasses. तो ब्रास के लिए क्या है, हमको very good surface finish मिलता है, surface finish. Okay, so this is about the rake angle, alpha B back rake angle. And generally if you talk about the rake or slope, when we talk about the rake or slope, so what is the use of, or what is the function that the rake face or the slope onto the surface give us? So सबसे पहले क्या देता है, it will give the convenient direction for the chip flow. Second one, it will give the necessary strength of the tool. Then it will use it will reduces the cutting forces. It can enhance the produced surface finish on the workpiece, and also it can increase the tool life. So these are the functions which can be done by this rake or slope on the top surface of the tool. Now again the second slope we can talk about. Again this is the downward slope on the top surface of the tool to the side. See, to the side. So this was from nose to the rear longitudinal axis. Now same slope, but slope which is perpendicular to this longitudinal axis to the side. So this, so see here, so this is the slope, this is our side rake angle. Please remember. Okay, now we will talk about this side rake angle. So rake angle over, now back rake angle over. Now see, this is the slope on the top surface of the tool to the side. See, this is the one side, slope ऐसा जा रहा है, isn't it, to the side, and which is perpendicular to this longitudinal axis. This is the axis of the tool, we know it, axis of the tool. So perpendicular to this and to the side, that is our side rake angle. Side rake angle alpha is the slope on the top surface of the tool, perpendicular to the surface of the tool to the side, perpendicular to the longitudinal axis, longitudinal longitudinal axis. This is our side rake angle. So side rake angle alpha s, the value of the side rake angle is generally, please remember, from 5 degree to 15 degree. कहाँ से कहाँ होती है? It is generally we are taking in the positive side. Okay, value of side rake angle how much? 5 degree to 15 degree. Now what are the effects? Okay, so as side rake angle goes on increasing, so side rake angle अगर आपने बढ़ा दिया तो क्या होगा? Again same effect like the rake angle, back rake angles. Only the thing is that, see, if this is increases, strength of the tool decreases, load carrying capacity decreases, forces decreases, power consumption decreases. What is about tool life? Please remember here, tool life not going to affect. Tool life remains unchanged. Remains unchanged. Okay, please remember. So these are the effects on the machining, some parameters. Okay, now see, when we are goes on increasing the side rake angle, where we are goes on increasing the side rake angle, please remember the amount of bending of chip in the widthwise direction goes on decreasing. The amount of bending of chip in widthwise direction reduces. Please remember. And it also guides the flow of the chip away from the job. Okay, so this is about the side rake angle. This is about the side rake angle. The value generally it is in positive side only. So side rake angle क्या करता है? It will reduce the bending of the chip in widthwise direction when it goes on increasing, and also it will guide the flow of the chips away from the job. So this is the effect of the side rake angle on the machining. Okay, so the next angles that we are going to see, that is the relief angles. Okay, so we are having the end relief angle and side relief angle. So let us see here where it is. So this is our nose radius or nose. This is the nose. Now see here, I will show you first the end relief angle. See, end relief angle is what? It is the angle between the plane perpendicular to the base. So this is the plane, this is the base, this is the plane perpendicular to the base, and this end flank. See, this is the end flank, isn't it? So see, so this angle is our theta E, that is our end relief angle. And if we talk about, this is our angle theta S. This is angle theta S. So this is the angle made by, see, the flank of the tools. This is the flank of the tool and the plane perpendicular to the base. See, this is the plane perpendicular to the base, and this is the flank just below what? This is what? This is the side cutting edge. इसके नीचे जो एंगल बनाया है साइड कटिंग एज के नीचे between the plane perpendicular to the base of the tool and this is what? Flank of the tool, isn't it? So this is our side relief angle. Now simply I can show here, say this is our workpiece. Okay, and say this is our tool. This is our tool. So can you see here any relief angle that we have provided? Okay, the tool with no relief angle here, we have provided zero relief angle. So we will discuss like this. So what will happen when there will not be any relief angle is provided on the tool? What will happen? So see, this is our workpiece and this is the tool. So in this condition, the tool is going to simply rub onto the workpiece. Okay, so there will not be any machining that going to happen. So simply the tool is going to rub on the workpiece. Please remember. So the main importance or main function of the relief angles onto the tool is that there should be some clearance between the work and the tool, so that machining can be possible. See, with the zero relief angles there won't be any machining. There only with the zero relief angles there will be no machining, but what? Only rubbing action, only rubbing. Tool will simply rub onto the workpiece. Now say if I provide this, say I provide this relief angle here. See, this is our theta. Of course this is theta E. Okay, so with this provision of the relief angle, see, there is immediate clearance between this work and tool and machining is possible. Understood? So relief angle is basically provided to have the cutting action rather the rubbing action. And what is the value of these angles? It is from 8 degree to 15 degree. So value of this theta S and theta E we can use up to this 18 degree to 15 degree. Now let us check what is the effect of these relief angles on our various machining say parameters we have taken, like what the force, strength, load carrying capacity, tool life and all. Okay, so let us see what will happen if we go on increasing the relief angles. What will happen? So suppose initially we are having this relief angle, say theta. Now I am going to increase this. So blue color will show the increase. Okay, now your tool is having, this is the relief angle. So what will happen? So when this theta goes on increasing, what we can write? Looking to the tool, of course the strength of the tool is पहले जैसी रहेगी या बढ़ेगी या घटेगी. Now initially tool like this, now the tool is looking like okay, so definitely strength of the tool क्या हो रही है? Decrease. Strength of the tool goes on decreasing. Load carrying capacity, of course, load carrying capacity also goes on decreasing. Okay, forces, of course, now it is only the point contact with the tool, so forces are going to be minimum. If forces are minimum, then power consumption, the power consumption, of course, it is also going to be minimum. And what is about tool life? See here, initially the wear land was this. Okay, this was a wear land having, this is the length. Okay, now see, when you are go on increasing the relief angle, so your wear land also goes on increasing. So more time between two successive regrindings, so that tool life, of course, it goes on increasing. Tool life is goes on increasing. So this is the effect on machining of this relief angle. So if you look at this effect of the rake angle, back rake angle, so same effects we can see when we go on increasing the relief angles. But please remember, relief angles basically what they do, they will eliminate the rubbing of the tool on the workpiece. So after seeing about the relief angles, let us now discuss about the effect of these cutting edge angles on the machining. So let us take this side cutting edge angle. So please show here the side cutting edge angle. So I will rub this relief angle, so we can easily see here the side cutting edge angle. So this is angle between the side cutting edge and say this is the longitudinal axis. This is the CS, Okay, the angle between the side cutting edge and longitudinal axis. This is our side cutting edge angle, and see, so end cutting edge angle. So this is the angle between the plane perpendicular to the side cutting edge. See, the plane perpendicular to the side cutting edge and the end flank, isn't it? And this is the flank. So this angle is actually our end cutting edge angle. This is our CE. Okay, the angle between the end flank and plane perpendicular to the side cutting edge. This is the end flank, this is the end flank, this is the major flank, side cutting edge. So plane perpendicular to the side cutting edge and this is the end flank. So this angle is nothing but the end cutting edge angles. Now see, if we look at this end cutting edge angles, so what is their effect? So please remember that whatever the surface finish that is going to produce in the operation is because of this end cutting edge angle. They are influencing, they are affecting the surface finish that is going to produce onto the work. How? Let us see here. Say this is our tool, okay, having the feed in this direction. We know that this is our end cutting edge angle CE, and this is our side cutting edge angle CS. This is our approach angle lambda. Okay, now when the tool is moving onto the surface like this, so definitely we are going to have the feed marks like this, isn't it? Okay, now if I take this feed mark into consideration, so see, the distance between the tip of these tools is nothing but the feed, isn't it? This is our feed, and the surface finish which is going to produce onto the tool is, say, this is the H max, which is nothing but the maximum peak to valley distance between these onto this surface. So surface finish, how we can getting, like, say, from the datum maximum peak to maximum valley, this is the difference we are having as the H max. Okay, so same way we are going to find here this value H for the surface finish, isn't it? So here you can see from these feed marks, this is the value of CE, and if I have this is the value of CS, isn't it? And say I will draw it, I exaggerate view of this. So suppose I am having this triangle like this. So this is our CS, this is the peak to valley distance H. Okay, say this is x1, this is x2, but no doubt this is totally what? This is the feed. Okay, and this is our angle, end cutting edge angle, CE. Okay, so from this, if we calculate the values of x1 and x2 and addition of this is equal to what? Nothing but the feed. Then how can you get the relation? Let us go on calculation. So I can write here tan of angle CS is equal to what? This x1 divided by CH, that is x1 is nothing but what? H times tan of CS, and here in this triangle. I am not giving the names, but see here, what is cot of angle CS? CE, cot of angle CE, adjacent side x2 divided by opposite side is nothing but the h. So here again x2 will be what? H cot C, isn't it? And we know that this x1 plus x2 is equal to what? This is nothing but this feed F. So right here x1 is what? H tan CS, H tan CS plus x2 is what? H cot C is equal to F. I will solve it here and let us see what we are getting. Peak to valley distance. So here this, if we take this H common into bracket, tan of CS plus cot of CE is equal to nothing but feed in millimeter per revolution. So what is the value of H? We are interested in H, or maximum peak to valley distance. I will write H max is equal to this F divided by tan CS plus cot CE, and this is nothing but what? This is directly giving us the surface finish. In the surface finish measurement, we are getting this RT value, RA, RZ, RT. Out of these three, we are getting this RT value, that is maximum peak to valley distances. How? That is H max divided by 4. Please remember, it is in microns. Okay, so this is the produced surface finish. जितना ये H max वैल्यू मैक्सिमम होगा उतना सरफेस क्या होगा? खराब होगा. जितना H max वैल्यू कम होगा उतना क्या होगा? पीक टू वैली डिस्टेंस जितना कम होगा उतना सरफेस फिनिश क्या होगा? बेटर होगा, isn't it? And you can observe this H max is depending upon the side cutting edge angle and end cutting edge angle. As the tan is increasing function, cot is decreasing function, you can write from here that when the CS goes on increasing, definitely H max goes on decreasing. When this end cutting edge angle goes on increasing, H max, maximum peak to valley distance, goes on decreasing. That means what? The produced surface finish is very good. Very good. Surface finish अच्छा मिलेगा. And the cot is decreasing function. As CE goes on increasing, what will happen? The H max is going to increase, isn't it? Because cot is what? Actually decreasing function. जितना आप बढ़ोगे उतना ये क्या होगा? वैल्यू घटेगा, H max वैल्यू क्या होगा? बढ़ेगा. Then surface finish is what? Goes on decreasing. Please remember. So this is the effect of this cutting edge angles. CS जितना बढ़ाओगे उतना सरफेस फिनिश अच्छा मिलेगा. ओके, एंड CE जितना बढ़ाओगे उतना सरफेस क्या होगा? डाउन होता चला जाएगा. प्लीज रिमेंबर दिस. सो बाय दिस फॉर्मूला we can say that yes, these side cutting edge and end cutting edge angles are influencing the produced surface finish on the component. That is important thing. And see the value of CS, value of CE, actually we can have value of CE from where to where? CE value can be from 8 degree to 20 degree. The value of CE we can have between 8 degree to 20 degree, whereas CS we know it is up to 90 degree, because CS is equal to 90 minus lambda, lambda is equal to 90 minus CS. So CS value up to 90 degree and CE value we can have up to 8 degree to 20 degree. Please remember, very very important. Many times this formula we require for solving the numericals. So surface roughness, how to calculate? From the maximum peak to valley distance or height, that is feed, which is in millimeter per revolution, and divided by tan of angle cutting side cutting edge angle and cot of end cutting edge angle C. Okay. Now the last parameter in the tool designation or tool signature we are going to see is the nose radius. So see here, this is the R is our nose radius, and what is the effect of this nose radius on the machining? So the last parameter, that is 7th parameter, that is the nose radius. So of course this nose radius is influencing the surface finish. It is influencing the surface finishing on the workpiece. Please remember. So how it is influencing the surface finish? Let us take the feed marks of this tool, and here I am now going to show you the nose radius. Okay. So if these are the feed marks of the tool with the nose radius. Okay, so this distance, this is nothing but our h, isn't it? Peak to valley distance. Okay, and now if I consider this is the throughout circle, okay, I approximated to this circle, then this is nothing but the h, isn't it? And from here, this is the r, the radius of the circle, and this distance will be what? This is again r, so this distance will be r minus h. And of course this is what? This is the feed, isn't it? Now say this distance will be now what? Feed by 2. Okay, so from this circle if I see, this is the r, okay, and this distance is nothing but the h. Then this will be what? R minus h, isn't it? So from this say diagram, what we can now write? R square is equal to this is the f by 2, this is f by 2 whole square, plus this r minus h whole square. Okay, so what we can write? This r square is equal to f square by 4 plus expand this a minus b whole square, this r square minus 2rh plus h square. So this r square get cancels, so what is left with? So this f square by 4 is equal to 2rh minus h square. So this h is of course very less compared to this r into h, so I'm going to neglect this. So what I will get? This h is equal to f square divided by 4 into 2r. So h will be what? F square by 8r, isn't it? So this is the formula we are getting when the nose radius is given. Then what is this peak to valley distance h or h max is equal to f square upon 8r. So of course when you are go on increasing the nose radius of the tool, your h max is going to be minimum, that is the surface finish that you are going to produce is very good. When the h decreasing, surface finish goes on increasing. Yes, but see, whenever you are going below above the optimum range of this nose radius, so what will happen? As the nose radius you go on increasing, there will be conversion of this point contact into the line contact, okay, between the tool and workpiece, and because of that the forces are going to increase when we increase the nose radius above the required optimum range. So because of that, when the vibrations and shattering are increases, this is of no use actually in the machining. So to have the surface finish within the limit, actually we want very good surface finish, we have to keep this nose radius in the range. That optimum range is nothing but from 0.2 to 1.2 millimeter, 0.2 millimeter to 1.2 millimeter. Say this is our nose radius and this is the RT, that is the surface finish. So if you have the nose radius between 0.2 to 1.2, it is okay. The surface finish is always good, but beyond that the surface finish goes on decreasing. That is, RT value goes on increasing means what? Surface finish is goes on decreasing. So this is how the nose radius is going to affect the produced surface finish on the component. So dear students, in this fashion we have seen the effect of the tool geometry on the machining by 6 tool angles and 1 geometry, that is rake angles, relief angles, cutting edge angles, and this last one is nose radius. Thank you.